Today we will be discussing how different types of substances dissolve by using either polar or nonpolar solvents.
First of all, what is dissolution and how does it work? Think about a cup of sugary water. If you get a cup of water, heat it up, pour some grains of sugar in, and mix them together, you will notice that after a while, the sugar grains aren't visible anymore. However, they are still there. If you taste the water, you can still feel the sweetness in it. This is because sugar dissolves in water.
In this case, sugar is considered the solute because it is what breaks apart into smaller pieces. Water is a solvent as it is what the solute, sugar, is poured inside to break it apart. Still, you can't just pour anything into water and expect it to dissolve. This is where the like dissolves like rule comes into play.
A polar solvent could only dissolve polar solutes, when a non-polar solvent could only dissolve non-polar solutes. You can tell if a molecule is polar or not polar by looking at the Lewis dot diagram. Non-polar molecules are symmetrical on all sides. The electronegativity from each electron domain must cancel out.
Polar covalent molecules contain dipoles, which are separations of charges within the molecule dependent on electronegativity and structural balance. For example, hydrochloric acid, HCl, has only two atoms, a hydrogen ion and a chlorine ion. However, the chlorine has a greater electronegativity value than the hydrogen, so more electrons are attracted towards the chlorine. This causes a dipole moment in which the hydrogen side is somewhat positively charged, while the chlorine side is somewhat negatively charged. Dipole moments could also be created when a molecule is not symmetrical with its electron domains.
Note that molecules such as H2O can be tricky, but you must pay attention to their three-dimensional geometries. It may seem like the two hydrogens are balancing out the charge distributions on a flat Lewis dot diagram, but in reality, H2O has a
Tetrahedral
geometry since there are four electron domains. Instead of being in a straight line, then H2O has a bent shape and uneven charges in its four electron domains, therefore making a polar.
Because of this polarity, water is considered a universal solvent because it could dissolve a wide variety of polar substances. Like for example, take the sugar that you would most likely use, sucrose. Sucrose could dissolve in water because it is a polar molecule.
However, keep in mind that water does not dissolve nonpolar substances. For that, you would use nonpolar solvents like hexane.
To test out how polar solutes dissolve in water, we will be setting up a radial paper chromatography. Chromatography essentially splits up the components of a colorful mixture by taking advantage of their polarities. Setting up the lab is easy. All you need is chromatography paper, a black marker, a clear cup, and water.
First, trace a circle with the opening of the cup on the chromatography paper and cut it out. In the middle of the paper, use a black marker to color in a dot. Poke a hole through the middle of the dot and roll up a different piece of paper into a cone-like shape, putting it through the hole. Get the cup and fill it with enough water for the cone-shaped paper to reach. Then, place a circle paper on top of the cup so that the bottom of the cone touches the water and allows to rise up.
From there, you will gradually see the water spread onto the circular paper, spreading the black marker from the middle. However, the black ink does not smudge and stays the same. The water dissolves it into its individual colored pigments. It takes some wetting, but you could watch as pink remains in the middle and does not continue spreading with the water too far. In contrast, at the outside of the circle, the blue pigment travels the farthest along with the water. How does that happen?
Remember, like dissolves like. When a nonpolar substance is placed in water, it would not dissolve or spread along with the water. However, a polar substance would dissolve. The larger the dipole moments in a molecule are, the more it would be broken down and attached to the water in a solution. Therefore, more polar pigments, which stay electrically attracted to the water, would travel with the solvent until it reaches the end of the circular paper. Therefore, the pink pigment is the least polar in the black marker mixture since it does not travel far. Blue is the most polar since it traveled the farthest.
determine which pigments are less or more polar by checking the outward distance they reach in the circular paper. Still, keep in mind that water is polar and using a non-polar solvent would bring different results. Since non-polar dissolves non-polar, pink would have traveled the farthest while blue would have stayed around the center.
So, what did we learn today? Well, we learned that like dissolves like. So basically, non-polar solvents could dissolve non-polar solutes, while polar solvents dissolve polar solutes. You could see that in paper chromatography, where, if you check the paper, the pigment that goes the farthest with the water is a polar pigment, while the one that doesn't move that much is a non-polar pigment. So thank you for tuning in. This was Danae, Georgiadis and Orfa Baez. Tune in for the next daily OD video.